Okay, today we're going to look at solving linear cubic systems of equations. A cubic is going to be when you have a y and an x to the third, an x cubed. So if you have a y and an x cubed or an x to the third power, that's when you're going to use these steps to graph. So you're going to make an XY table, and you're always going to have the x values from -3 to 3. -3, -2, -1, 0, 1, 2, 3. Those are always going to be the numbers in your table for the cubics. You're going to use your calculator to complete the table. Then you're going to plot the points. Make sure you plot the points and then connect them in a smooth, rounded curve. You only have to plot the points that fit. There are going to be points that are not going to fit. That's okay. Don't forget to put arrows on the graph and label the graph with the equation. All right, so now we're going to solve the linear cubic systems by graphing. So here's our first example. Y equals the quantity x minus 1 cubed, and y equals x minus 1. Let's start with the linear first. Y equals x minus 1. I know it's linear because there's no exponent. This is in the form y equals mx plus b. There's that invisible 1 in front of the x, so our slope is 1, or 1 over 1, which means we're going to rise 1, and we're going to run right 1. Now our y-intercept, that's the b, which is right here, the minus 1. So -1 on our y-axis is where we start, and our slope is 1 over 1, so we rise 1, right 1, rise 1, right 1. Once you have a few dots, get that handy-dandy straight edge, connect them. Don't forget your arrows. And then write the equation, y equals x minus 1. Now we're going to take a look at this cubic. I know it's a cubic because the exponent is a 3. So y equals the quantity x minus 1 raised to the third. We're going to have an xy table, and we're always going to start at -3, -2, -1, 0, 1, 2, 3. Now we're going to go to our calculator, and we're going to find the values to finish this table. Okay, so we need a graph page, and we're going to put in our cubic here, which we had parentheses, x minus 1, close it, use the caret for raised to the third, hit enter, and here's our cubic. Now to get our table, remember it's Control T for table. We need to arrow up till we get to where x is -3, and we need to copy this table from here all the way down until we get to where x is +3. Okay, copy those numbers down. Okay, so from our table, we saw that this was -64, -27, -8, -1, 0, 1, and 8. Now we're going to plot these points. I can't plot -3, -64. It doesn't fit on my graph paper. Neither does -2, -27. But I can plot -1, -8. I can plot 0, -1. Notice that's a point of intersection. I can plot 1, 0. That's also a point of intersection. I can plot 2, 1. That's also a point of intersection. And I can plot 3, 8. Now, hopefully you paid attention to the shape of the graph when you were on the calculator, because the cubic has an odd shape to it. Make sure it has arrows. Make sure you label the equation. Okay, here we have 3 points of intersection. So our solution, we have the points 0, -1, 1, 0, and 2, 1. And we'll go back to the calculator so you can check on your calculator and see how to do this there also. So now we're going to turn off the table, so Control T again. We're going to tab up so that we can put in our line, which was y equals x minus 1. Press enter. I'm going to move these equations out of the way. we want to find those points of intersection, and there's 3 of them, so we're going to find them all at once. We're going to do menu, geometry, points and lines, and then 4 for intersection points. Click on one graph, click on the other graph, hit escape. If you need to, you can grab the points and separate them a little bit so that you can see them, but our solutions are 0, -1, 1, 0, 2, 1. Make sure you write your points in parentheses. There you go. Okay, we're going to do one more. Again, we're going to start with the linear. Y plus 3 equals 1/2 x. We need to subtract 3 from both sides. Y equals 1/2 x minus 3. Now it's in y equals mx plus b form. So the m is 1/2. So we're going to rise 1. We're going to run right 2. Our y-intercept is that b, which is -3. So on the y-axis, we go to -3. Up 1 over 2, up 1 over 2, up 1 over 2. Once you have a few of those, get your handy-dandy straight edge. Connect them. Arrows. Write the equation, the original equation, y plus 3 equals 1/2 x. Now we're going to do our cubic, and I know it was a cubic because there's an x to the third. Y equals x to the third plus 4. We need an x, y table. When we have a cubic, it always starts at -3, -2, -1, 0, 1, 2, and 3. All right, let's go to the calculator and fill in our table. So we're going to insert a page, Control Doc, and we want a graph page. So our cubic this time is y equals x raised to the third, arrow out of the exponent, plus 4. We hit enter. Here's our cubic. We do Control T to see the table. We need to arrow up till we see x equals -3. Now we're going to copy the table from -3, -23, all the way down until x is +3. Okay, copy down the table. Okay, we found that this was -23, -4, 3, 4, 5, 12, and 31. I cannot plot -3, -23. I can plot -2, -4. I can plot -1, 3. I can plot 0, 4. I can plot 1, 5. And I cannot plot 2, 12, or 3, 31. So my graph is going to do this and then this. Now my solution are the points where the graph intersects, and it looks like our graph only intersects at one point this time, and that's the point -2, -4, and that's our answer. We'll check that on our calculator, and then we're done. So let's turn off the table, Control T. We need to tab up so we can put in our line, which was y equals, I need my fraction key, Control Division, 1 over 2, get out of my fraction, x, and it was -3, hit enter. Okay, there's our line. Now we go to Menu, Geometry, Points and Lines, Intersection Points. Click on the cubic, click on the linear, escape to get out of it, and you can see that our only point of intersection is the point -2, -4. Okay, that's it for today, guys. Bye.